Welcome back everyone to the Baldur's Gate 3 in Unity tutorial series. In this episode we are going to add combat style movement. So this is where we can point and click, we'll see a preview path, and our character will follow that path, automatically interacting with things like ladders if they are along that path, and then continuing on to the final destination. When we toggle it into a turn-based mode, we will see that we can preview the path before we start moving along it. If it's too far out of range, the color will change to indicate that this is out of our, we're out of movement budget at that point. And this is going to be the foundation for what we use when we actually fully establish our turn-based combat modes. So let's jump right into it. So in our scene, we're going to create an empty object, which I'll just call NavMesh, and we're going to add a NavMesh surface to it. Let's just bake it immediately with the default settings and kind of see what we get here. Now there's some problems, so let's just clear it out. We're going to go to our player and turn them off and bake it again, and you can see immediately that, at least for me, it gets rid of that little problem there. Let's open up the agent settings. The default, I think, is 0.5. I found that setting it to 0.25 allows my stairs to actually get baked properly. Now after we bake it, we can turn the player back on, and that should work the way we want. Now we're going to make a few scripts here. We're going to make a NavMesh path preview and a player click navigation controller. The NavMesh preview is going to be very, very similar to the arcline preview we used for our jumping, and the player click navigation controller is going to be where really all the meat of this happens. So let's jump into that. We're going to make a private enum called navigation preview mode with two options, real-time exploration and turn-based exploration preview. Then we'll make a header here called input. We'll say serialized field, bool, click navigation enabled equals true, serialized field key, turn-based preview toggle key equals key.t. So basically we're just going to be pressing the T button to toggle on our turn-based mode where we can preview our navigation ahead of time. We'll make another serialized key for canceling navigation, which we'll just have as escape, and a bool for cancel navigation on manual input equals true. That just means if we're in the middle of navigating during, real-time mode, we can just start moving like we have before, and it'll cancel it, and the direct movement control will take over. We'll make another header for targeting. We'll have a bunch of serialized fields here for the camera, for a layer mask, a couple of floats for navigation ray distance, NavMesh sample distance, and an INT for our area mask, which we will call navmesh.allareas. We'll make a header for the mode, which will have a few serialized fields for navigation preview mode, and a couple more serialized fields that'll have a minimum of 0. These will be floats, turn-based movement budget meters, and budget tolerance. This is basically how far can we move when we're in turn-based mode. Like, what is our movement limit? 9 meters gets you close to sort of the 30 feet default of D&D. So if we find ourselves exceeding that distance, then the color of the line preview, the path preview, should change to something to indicate that, hey, this is too far for you to go in one move. And the budget tolerance is just there to give you a little bit of wiggle room. And these are just settings that we're going to implement in case a NavMesh wasn't generated ahead of time. Then we'll make a header for our ladders. We'll have some serialized fields for player movement, ground and obstacle detection, player action controller, NavMesh path preview, and then we'll have a private read-only dictionary, object ladder climb, ladder by link equals new, private read-only list, game object, runtime link objects equals new, private animator, a private INT called movement parameter hash, a private NavMesh path called reusable path, and a private navigation path query, which we will create later, which we'll call live preview query. We'll have a private vector3 called committed destination, a bool for has committed destination, another bool for is navigating, and another one for is traversing off mesh link. Then we'll have some NavMesh data stuff here, runtime NavMesh data, and NavMesh data instance, which is our current runtime NavMesh data instance. And then we'll have a private bool for is navigation in progress. I actually made a mistake here. This bool should be public. I fix it later, but I'm doing it very quickly, so I would recommend you just take care of that right now. Then in our awake method, we'll have a bunch of methods here that just initialize everything. And in start, we'll say if build runtime navmesh if missing and has navmesh near is false, transform.position is passed in as an argument, build runtime navmesh. If create runtime ladder links, then we do the create runtime ladder links method. We're going to be putting in a lot of methods here that haven't actually been created yet because we're going to put them farther down in this script. So don't stress about that. Just know we're going to add them. I forgot to add a bool here for the runtime NavMesh added. Let's make sure we put that in there. We'll say runtime NavMesh data instance.remove, runtime NavMesh added equals false. In our update method, we're going to say if click navigation is not enabled, return. Then we'll have our handle mode toggle method, and we'll say if should cancel navigation from input, then cancel navigation and return. And then we'll have path preview.hide. A lot of the path preview stuff should look very familiar because it is almost identical to the arc line preview that we created in the last video. We'll say if preview mode equals navigation preview mode dot turn-based exploration preview and is navigating is false, then update live turn-based preview. If was primary click pressed and is pointer over UI is false, then we can go ahead and handle the primary click. If is navigating, update navigation. Then we'll make our cache references method. We'll say if player move is null, player move equals get component player movement. If ground detection is null, then same thing. Ground detection equals get component, ground and obstacle detection. If action controller is null, then our action controller equals get component player action controller, and then the same thing for our target camera, but this time we're specifically looking for camera.main. If player move does not equal null, animator equals player move.animator. If animator still equals null, animator equals get component animator. Then we'll make our ensure agent method. If our agent is null, then the agent equals get component navmesh agent. If our agent is still null, agent equals gameObject.addComponent navmesh agent. If we don't have one, add it at runtime. Then we'll set all of these aspects of the agent: the speed, the acceleration, the stopping distance, auto braking, auto traverse off mesh link, update position, update rotation, and whether or not it's enabled. Then we'll make our ensure preview method. If path preview is null, path preview equals get component navmesh path preview. If path preview is null, path preview equals gameObject.addComponent navmesh path preview. Then we'll make our handle mode toggle method. Now for now, I'm just treating this as if we're doing everything with mouse and keyboard. Later on, I will go through and actually make sure that this also works well with gamepad. Previously in our videos, I've always made sure that everything was working with both, but this video is already getting very lengthy, so we're just going to stick to mouse and keyboard for now. But don't worry, if you're wondering how to get all of this working well with gamepad, we will come back to it and make sure that all works properly in a future video. Now our handle primary click method is pretty straightforward. If preview mode equals navigation preview mode dot turn-based exploration preview, if live preview query is executable, begin navigation with live preview query as an argument. Then return. If try build navigation path from pointer, false, out navigation path query, and query.is executable, begin navigation query. Else path preview.show query.corners query.hasValidPath query.isOverBudget. Then we'll make our update live turn-based preview method. If try build navigation path from pointer, true, out live preview query, path preview.show live preview query.corners, live preview query.is executable, live preview query.isOverBudget, return. Path preview.hide. Then we'll make a private bool, try build navigation path from pointer, which will take bool, use movement budget, and out navigation path query, which we'll call query. Query equals default, camera to use equals target camera does not equal null, question mark, target camera, camera.main. Mouse equals mouse.current. If camera to use is null or mouse is null, return false. Then we'll make array called ray, which will equal camera to use dot screen point to ray, mouse dot position dot read value. That position should be lowercase. I fixed that later, but once again, probably easier to just fix it now. If physics.raycast, ray, out, raycast, hit, navigation ray distance, navigation raycast layers, query trigger interaction.ignore is false, return false. Return try build navigation path hit.point, use movement budget, out query. Now let's actually make that bool, which we'll call try build navigation path, takes vector 3 as an argument, and a bool called use movement budget, and out navigation path query, which we'll call query. Query equals default. If try get current nav mesh position is false, out vector3 nav start, return false. If navmesh.sample position requested destination out navmesh hit destination hit, navmesh sample distance area mask is false, query equals navigation path query dot invalid requested destination, return true. Reusable path dot clear corners, bool path found equals navmesh dot calculate path nav start destination hit dot position area mask reusable path. If path found is false, or reusable path dot corners is null, or reusable path dot corners dot length is 0, query equals navigation path query dot invalid destination hit dot position, return true. Vector3 as an array called corners equals reusable path dot corners. Then we'll make a float called path length equals calculate path length corners. I'll have a float called budget, which is use movement budget question mark turn-based movement budget meters colon 0. I'll have another bool called has complete path, which will be reusable path dot status is equal to the navmesh path status dot path complete. We'll have another bool called is over budget, which is our budget greater than 0, and path length is greater than the budget plus the budget tolerance. Private void begin navigation. Navigation path query query. If query is executable is false, or activate agent for navigation is false, return. Committed destination equals query.destination, has committed destination equals true, is navigating equals true, is traversing off mesh link equals false, prepare navigation control. Agent.isStopped equals false, agent.reset path. If agent.set destination, committed destination is false, cancel navigation, return. Path preview.show, query.corners, true, false. Then we'll make our update navigation method. If agent is null or agent is not enabled or the agent is not on the nav mesh, then we cancel navigation and return. If agent is on off mesh link and is not traversing off mesh link, start coroutine traverse off mesh link and return. If is traversing off mesh link, set animator movement and return. Update animator from agent, rotate toward agent velocity, update committed path preview. When it comes to the setting the animator movement, one of the problems we'll run into is that we've been using root motion to handle our movement when we directly try to move the character with our controller or with WASD. We want to still be able to have our character animating when we move, even if it's the NavMesh based movement. So we're going to have to go back into our player move script later to tweak some things to make sure that that all works properly. But we will address that later. Now we're going to make our prepare navigation control method. If player move does not equal null, player move.set control state false false. If ground detection does not equal null, ground detection.set gravity enabled equals false, ground detection.set obstacle detection enabled is false, and reset our vertical velocity. Then we'll make our restore player control method, set animator movement 0. If ground detection does not equal null, reverse all those things. Then we'll make our complete navigation method, stop our agent, disable the agent for manual control, restore player control, set is navigating and is traversing off mesh link and has committed destination all to false, and put path preview back to hide. Next we'll make our cancel navigation method. We'll say if is navigating is false and has committed destination is false, return. Stop our agent, disable the agent for manual control, restore player control, is navigating is false, is traversing off mesh link is false, has committed destination is false, path preview.hide, just like before. Now we'll make our stop agent method, which just says if our agent is null, or not enabled, or not on the mesh, return. Otherwise, agent is stopped, agent.reset path. And then we'll make our activate agent for navigation method. If the agent is null, make sure we have one. If agent is still null, return false. If agent is not enabled, enable them. Restore agent transform sync. Agent.isStopped equals true. Bool agent ready equals ensure agent on navmesh. If agent is ready equals false. Disable agent for manual control. Return agent ready. Then we'll make our disable agent for manual control method. If the agent is null, return. If agent.enabled and agent is on a navmesh, agent.isStopped is true, and reset the path. Update position is false, update rotation is false, enabled is false. Now let's make our coroutines. We're going to make our traverse off mesh link 1 by first setting some things. We'll have is traversing off mesh link to true, is stopped is true, update position is false, update rotation is false. We'll make an off mesh link data called link data equal to agent.current off mesh link data. Then we'll make an object called link owner equals link data.owner. If link owner does not equal null, and ladder by link.try get value, link owner out ladder climb, which we'll call ladder, yield return traverse ladder link ladder. Else yield return traverse unknown off mesh link link data. If agent does not equal null and agent.enabled, if agent.is on off mesh link, agent.complete off mesh link. If sync agent to current transform is false, cancel navigation, yield break. If has committed destination, prepare navigation control, restore agent transform sync, agent.isStopped equals false, agent.setDestination, committed destination. If agent does not equal null and agent.enabled, we're going to restore agent transform sync. Is traversing off mesh link is false. Now we're going to make the traverse ladder link coroutine. If ladder is null or ladder.can interact with the game object is false, yield break. We'll make a bool called climb finished and initialize that at false. Then we'll make a void on climb finished ladder game object interactor. We'll say if finished ladder equals ladder and interactor equals game object, climb finished equals true. Ladder.climb finished plus equals on climb finished. Ladder.try interact game object. Now you can see here that there's some things in our ladder script that are missing, which we're going to have to add later. We will get to that after we finish up writing this script all out. Now let's make our traverse unknown off mesh link coroutine. We'll say vector3 start equals transform.position, vector3 end equals link data.end position plus vector3.up times agent does not equal null, question mark, agent.base offset, colon, 0. Float elapsed equals 0f, while elapsed is less than unknown off mesh link traverse duration, elapsed plus equals time.delta time, float t equals mathf.clamp01, elapsed divided by the unknown off mesh link traverse duration. Transform.position equals vector3.lerp, start, end t. Yield return null. Transform.position equals end. Now I forgot to create this unknown off-mesh duration, so let's put that up here under ladders. We'll say bool, create runtime ladder links equals true, serialized field float, unknown off-mesh link traverse duration is 0.35f, and we'll make a header below that for references. I kind of messed up that organization earlier. Now let's make our update committed path preview method. If agent is null, or has path is false, or path is null, or agent.path.corners.length is 0, return. Path preview.show agent.path.corners true false, and we'll make our update animator from agent method. Float speed percent equals navigation speed greater than 0, question mark mathf.clamp01 agent.velocity.magnitude divided by navigation speed colon 0. Set animator movement to speed percent. Then we'll make our set animator movement method, which will take a float. We'll just call it value. If player move does not equal null, player move.set external movement value, return. That's a method we're going to create inside our player movement script later to do what I was describing before of making it so that we actually animate movement when we're traveling along the nav mesh so our player doesn't just kind of float along. Then we'll say if animator is null, return, animator.setFloat movement parameter hash value, animator damp time, time.delta time. Then we'll make our rotate toward agent velocity. We'll make a vector3 called velocity, agent.desiredvelocity.square magnitude greater than 0.01f, question mark agent.desiredvelocity, colon, agent.velocity. Velocity.y equals 0. If velocity.square magnitude is less than or equal to a very small fraction, return. Quaternion, target rotation equals quaternion.look rotation, velocity.normalized, vector3.up. Transform.rotation equals quaternion.rotate towards, transform.rotation, target rotation, rotation speed, times time.delta time. Next, let's make our ensure agent on NavMesh bool. If agent is null or agent is not enabled, return false. If agent is on the NavMesh, update agent base offset, return true. If NavMesh.sample position, transform.position out, NavMesh hit, NavMesh sample distance, area mask is false, then we'll make a warning and clarify that it's from this script and say player is not close enough to a NavMesh. Then we'll return false. If preserve vertical offset from NavMesh, agent.base offset equals transform.position.y minus hit.position.y. Return agent.warp hit.position. Then we'll make our restore agent transform sync method. If agent is null, return. Agent.update position equals true. Agent.update rotation is false. We'll make a bool for sync agent to current transform. If agent is null or not enabled, return false. Otherwise, we'll say if navmesh.sample position transform.position out navmesh hit, navmesh sample distance, area mask. Then we'll make another warning from this script specifically saying could not sync the navigation agent after traversal because the player is not close enough to a nav mesh, and we'll return false. Next, we'll make a private bool try get current nav mesh position, which will take a vector3 nav position equals transform.position. If navmesh.sample position, transform.position out navmesh hit sampled position, navmesh sample distance, area mask, then nav position equals sampled position.position return true. If agent is not null, and agent is enabled, and it's on a navmesh, nav position equals agent.next position minus vector3.up times agent.base offset return true, and finally return false. Then we'll make our update agent base offset. If preserve vertical offset NavMesh is false or agent is null, return. And we'll do this same if statement about navmesh.sample position. We'll say agent.base offset equals transform.position.y minus hit.position.y. We'll make another bool, has navmesh near, which takes a vector3 as an argument. Then we'll say return navmesh.sample position out underscore navmesh sample distance area mask. Next, we'll make our build runtime navmesh method. We'll make a couple of lists here, one for sources and one for markups. Navmesh build markup ignore player markup equals new. Root equals transform. Ignore from build equals true. Markups.add ignore player markup. Bounds equals new bounds. Transform.position. Runtime navmesh bounds size. We'll say navmesh builder.collect sources, bounds, runtime navmesh source layers, runtime navmesh geometry, 0, markups sources. We'll say if sources.count is 0, then we'll make a log warning again saying runtime navmesh build found no sources, return. We'll say navmesh build settings equals navmesh.get settings by ID, runtime navmesh agent type ID. Runtime navmesh data equals navmesh builder.build navmesh data settings sources bounds vector3.0 quaternion.identity. If runtime navmesh data is null, then we'll do another warning saying runtime navmesh build failed, and we'll return. Then we'll say runtime navmesh data instance equals navmesh.add navmesh data, runtime navmesh data instance, runtime navmesh added equals true. Then we'll create our create runtime ladder links method. Ladder climb array called ladders, and we're going to find all the ladder climbs. And we'll say for each ladder climb, ladder in ladders, if ladder is null, or ladder.bottom entry point is null, or ladder.top entry point is null, then continue. Game object, link object equals new game object. We'll say runtime navigation link, ladder.name. Link object.transform.set parent, ladder.transform true. Link object.transform.position equals ladder.bottom entry point.position. Navmesh link equals link objects.add component, navmesh link. Link.start transform equals ladder.bottom entry point. Link.end transform equals ladder.top entry point. Link.bidirectional equals true. Link.activated equals true. Link.area equals 0. The cost modifier is -1. Agent type ID is runtime navmesh agent type ID. And link.update link. Ladder by link equals ladder. Runtime link objects.add link object. Then we'll create a private bool, should cancel navigation from input. Basically, we're saying here that if we've pressed any of the keys that indicate that the player is trying to move, and we've set it up so that doing so is going to end the point and click style movement, then when we detect those buttons are pressed, end that movement and pass control back over to the player. Then we'll make a very simple static bool for was primary click pressed, return mouse.current does not equal null, and mouse.current.left button.was pressed this frame. Make another static bool for whether or not the pointer is over UI. We'll say event system.current does not equal null, and event system.current.is pointer over game object. Then we'll make a private static float called calculate path length, vector3 array corners. If corners is null, or corners.length is less than 2, return 0. Float length equals 0. For int I equals 1, I less than corners.length, I plus plus, length plus equals vector3.distance, corners I minus 1, corners I. Return length. Now we'll finally make our private read-only struct navigation path query. It's going to have a bunch of read-only things here. A vector3 called destination, a vector3 array called corners, a float called path length, a bool for it has valid path, a bool for is over budget, and a bool for is executable. Then we'll make a public navigation path query that takes vector3 destination, vector3 array corners, float path length, bool has valid path, bool is over budget, bool is executable. And as you probably guessed, we will make all of these equal to each other. Then we'll make a public static navigation path query invalid vector3 destination, return new navigation path query destination, a new array destination, 0, false, false, false. Okay, that's the big one done. Now we're just gonna blitz through the NavMesh path preview because this is virtually identical to the arcline preview that we made in the previous video. I'm typing it all out so you can actually see it and you can pause and make sure yours is exactly like mine if you want to make it identical. But the principle here is exactly what we did last time, so I'm not going to spend any time explaining what you're seeing on screen here. So what I want to do while this is all blazing by on screen is spend a little bit of time actually just talking to you about what it is we just achieved with the last 20 minutes of work that we just coded through. All of the movement we've been doing up until now has been directly controlled by the player, right? That root motion is really nice for exploration, but it's going to be clunky when we're trying to do this NavMesh style stuff, which is how we're going to do all of our pathfinding. And we need that pathfinding for more Baldur's Gate style combat movement. So when we're in combat, the player needs to be able to select a destination, preview the path, understand exactly how far their character is going to move, and then they commit to that movement. So we're adding a NavMesh agent that will calculate and follow a path across these sort of baked surfaces. That's those blue colors that you saw inside the editor when we set that up at the beginning. This will make it so that when we left click somewhere in the world, we're raycasting from the camera through the mouse position. And as long as that ray hits something that can be used as a target, then we do so. Once that navigation finishes or is canceled, we stop the NavMesh agent, we clear its path, we disable it, and completely return control to the normal movement system. We need to go into our player movement script and fix some things. We're going to add a private bool called hasExternalMovementValue and a private float called externalMovementValue. We'll make a method called applyMovementAnimatorValue, which takes a value. We'll say that if the animator is null, return, and then essentially the logic we were using before to set our animator values we'll do inside this method. We'll make a public method called setExternalMovementValue, which takes a value. HasExternalMovementValue is true, externalMovementValue equals the value, and then we'll apply our MovementAnimatorValue. Then we'll make another one, which just clears this all out and resets it. Now we're going to replace some of these spots with this kind of logic. In our set movement input enabled, we need to fix that. And then in our update method, we're going to replace this line with that method that we've created. Then we'll go down and do the same thing down here. Again, it's that same line, we're just replacing it with this. Then we need to make a public bool in our player action controller. Has active or busy action equals our active action does not equal null, or has busy action method. We're going to put a cache actions method in our awake method, and we'll create that down here. It'll say actions equals get components character action. I forgot to actually create that. Private character action array, call it actions. And we'll make a serialized field for our player click navigation controller. In our awake method, we'll say if click navigation controller is null, get component player click navigation controller. Then we'll make a bool has busy action. If actions is null or the length is 0, cache actions, and then we'll loop through our actions, and if they're busy, we'll return true. Otherwise, we'll return false. Then we'll make another bool for is click navigation in progress, which will do exactly what it sounds like it's doing. And remember, that needed to be public for this to work properly. Now we're actually going to plug that bool in our select action. We'll say if has busy action, return. If is click navigation in progress, return. And in our ladder climb, we need to add a couple of things. We're going to make a public event for our action, ladder climb game object climb finished. We'll make a public transform for our bottom entry point and another for our top entry point. And we'll expose our isBusy bool. Then down in our finish climb method, we will actually invoke that event. That should do it. So jumping back into the editor, we're going to add our NavMesh path preview to the player, as well as our player click navigation controller. I'm going to sync up these references. You don't have to. They should automatically work based on the awake method and when things initialize. And that should be everything. So let's hit play and see. And there we go. It's all working as we expect. We should be able to navigate all around these different places. Our path preview should correctly show us where we're going to end up. We should be able to seamlessly go up and down this ladder and continue along our nav path. Yes, that is all working. Movement for combat is basically done, and now it's just going to be syncing it up when we have initiative and turns and all those kinds of things. But this lays the foundation for it and gets us very far. Now, if we go into the turn-based mode, we'll see a much clearer example of it where you actually can hold out the line ahead of time, see exactly the path you're going to take to get to a certain destination. You see it turns yellow when the place I want to move to is out of range in a single turn. Thanks to everyone who is subscribed to the YouTube channel and subscribes on Patreon. Greatly appreciate you and couldn't do this without you. In the next video, we are going to start actually fully implementing the combat system. So look forward to that in the next one, and I will see you there.